So the Caesar cipher is this like really simple cryptography system that was popularized by Julius Caesar way back in like the 1st century BC during one of his military campaigns. And how it works really is pretty simple. So let's say you have this plain text text you want to encrypt. Let's say it's just a single word like hello. So what you do here is you have to pick out a key, which can be pretty much any number, but really the only effective ones are between 1 or 25. So let's say our key, our K, is going to be 6. And all you really have to do for this is you just offset your plaintext characters by your key. So if you look over here where H is, and we just go up 6. 1, 2, 3, 4, 5, 6. So our first letter of our ciphertext is going to be an N. We go over to E. We see the index of E is at this 4, so we can just jump up here to 10, which is going to be a K. Next two letters are L's, which is 11. So we go up 1, 2, 3, 4, 5, 6. It's going to come out to be R, R. And then finally we have O, which if we just go up 6, that's going to be a U. So this is our plain text. This is our ciphertext, or C. So in order to decrypt this back into our plain text, all we have to do is get the inverse of our key, essentially. So our key to go back is just going to be -K. So we look at N, we go up 1, 2, 3, 4, 5, 6 back to H. We do the same thing with E, we go from K to E. So 1, 2, 3, 4, 5, 6 back to E. Our R's 1, 2, 3, 4, 5, 6, and then O. To get O from U is just 1, 2, 3, 4, 5, 6. Right, pretty simple, pretty easy, but there are some pretty obvious flaws with this. First of all, the same character, it gets encrypted to the same. So all L's will become R's, all O's will always be U's. So if you had like a long text, like so it was sunny, it was cloudy, it was rainy. If you were to encrypt this, all the its would encrypt to the same two characters. And let's say our K was 6 again. Right, so all our I's become 1, 2, 3, 4, 5, 6. All our I's would become O's. All of our T's, 1, 2, 3, 4, 5, 6, would become Z's. And then the same thing for our was. So we go to our W, so 1, 2, 3. And when this happens, when you're sort of at the end, you just loop back around. So we got 1, 2, 3, 4, 5, 6. And then from A, 1, 2, 3, 4, 5, 6, that's going to be an F. And then S, 1, 2, 3, 4, 5, 6. Right. And then we could do the same thing for the other letters. I'm not going to, but there's a pretty obvious flaw in this, right? So there's only so many valid 2 and 3 letter words in the English language. So if you were someone who didn't have this original plaintext at all, and you didn't know the key, but you had this, and then there was some space here, some space here, some space here, you can look and say, hey, there are these letters that are repeating. So you could just look through all the other words. You could look through things like at, to, be for those, the, was, for the 3-letter words. So it may take some time, but it's pretty easy to attack a Caesar cipher if you just have a pencil and paper, and well, you know the language that the plaintext is going to be. But it's really, the Caesar cipher is really a really good starting point for understanding different cryptography, because there's some commonalities in this. You always have a plaintext, you'll have a ciphertext, and you have some sort of key. You'll also have some sort of encryption and decryption function. So the encryption is when you go from plaintext to the ciphertext. So it's normally denoted by an E for an encryption. Then you really have some sub K for your key. And essentially what this is to get your ciphertext. Mathematically, I'll explain this in a second. Right, okay. So let's say we wanted to work with a single character. Let's say our plaintext was, let's go with an M. Okay, so your M has some sort of index in the alphabet you're working with. In this case, M's index is 12. And then let's say our key, or our K, in this case, let's say that's going to be just, let's do 20. So to do the encryption, we can do 12 plus 20, right? And that comes out to 32. You'll notice that there's no 32nd character in our alphabet, which is why we have this here, this mod 26. So essentially this gives you a remainder after division, right? So if we were just to do, right, that goes in once. We do our long division, and we just get 6. So 32 mod 26, that is congruent, basically equal to 6. And we can kind of just confirm that, where if we go over, we go to M, and then we go up 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yep, we're at number 6, which is G. So our ciphertext is going to be 6. And so that's how we encrypt things in the Caesar cipher. To decrypt, we do what we did over here. We do our negative K. So for decrypting with a K, right, to get our plain text back, it's pretty much the same setup, right? But you just switch some things around. So you have your ciphertext you want to do, your numerical version of it, and then you do plus minus K mod 26. So let's say we want to go to our G. I'll just mark this down. That's a G. Let's say we want to go G, so that's going to be 6 plus minus 20 mod 26. So it's going to be negative 14 mod 26. And so if we do this out the long division way, we're eventually going to come out to getting the letter M, right? So that's our plain text. So you'll see the sort of mod character, the congruency, interactions with key in like all cryptographic systems. So the Caesar cipher is a really good way to get introduced to these kinds of systems. And it really lays the groundwork for some future systems like veneer ciphers or just general substitution ciphers. But yeah, it's just a really good start to start off as.